some higher GCSE 9 to 1 Maths past paper exam questions on histograms and frequency density, which you can download below in the description. Let's do this. Hey there guys, welcome back to the channel. If this is your first time here and you're trying to get the best grade in maths you possibly can, let me help. Start now by subscribing. Okay, before we get to the questions, I put in this page from my brand new formula booklet, which if you haven't checked out yet, is linked down below in the description. Basically, the secret to histograms is the area of each bar represents the frequency in that interval. If you want this explained thoroughly, check out the top video in my histograms playlist, which is linked down below. And first up, the table shows information about the distances 570 students travelled to a university open day. Part A, draw a histogram for this information. Okay, so it's classic, they haven't given us a scale for the frequency density. So what we need to do is find the frequency density for each interval, and then we can devise a scale. So frequency density is frequency divided by interval width. So first up, we have 120 divided by 20, so that's 6. Then we have 90 divided by 30, so that's 3. Then we have 120 divided by 30, so that's 4. And then 140 divided by 70, so that's 2. And then 100 divided by 50 is 2. So the biggest frequency density we have here is 6. So we can use every 5 little squares as 1. Okay, so there's our scale then. Now it's just a case of drawing rectangles with the base lengths as the interval widths and the heights as the frequency density. So you should get this. Okay, so your histogram should look something like this. Now part B annoyingly wants us to estimate the median distance. So if we put all of these students in order of the distance they have travelled, we would want the one in the middle. Now if we do 570 divided by 2, we get 285. So we need to try and find where the 285th student would be. So we go back to our frequencies and we're going to add them up cumulatively until we get a number 285 or greater. So starting from the top, we have 120, then 210, and then 330. So our 285th person is going to be in there. Now, out of this 120 people, to get from 210, we're going to need 75 people in 2 this interval. So we want to go 75 out of 120 into this interval. So 75 out of 120 is the same as 5/8. Now the interval width in here is 30, so we want to go from 50 and then we're going to add on 5/8 of 30. So 5/8 of 30 if you use your calculator, it's 18.75. So our median distance then is going to be 50, add that. So 50 add 18.75 gives us 68.75. Okay, next up, a bit nicer because we don't need to faff around drawing a histogram. So this histogram shows information about the 134 members of a sports club. We're told 20% of the members over 50 are female. We want to find an estimate for the number of female members who are over 50. Okay, so what we need to do then is find an estimate for the number of members over 50 and then find 20% of that. So find 50 down on the x-axis. So it usually lives between 40 and 60. So what we need to do is find the area in the bars to the right of that point. So we want all of the area to the right of that blue line. So first up, between 50 and 60, we have an interval width of 10. And our frequency density, so every two little squares is 0.1, so this is 1.4. So the area in here is 10 times 1.4 which is 14. So, as an estimate, we have 14 people between 50 and 60. Okay, and then for the last bar, our interval width is 30. And our frequency density is 0.7. So 30 times 0.7 is 21. So our estimate for the members over 50 is 14 and 21, so 35. Now the females are 20% of that. Which is 7. Stop. So we're drawing another histogram. So the table shows information about the heights of 150 students, part A, draw a histogram. So with this one, they labelled absolutely none of it. So I've already put in the height scale along the bottom. So starting at 140 on the left, every 10 little squares is 10. And also don't forget to label. Okay, so again then, we now need to find the frequency densities. So for the first one, we are doing 15 divided by 10, so that's 1.5. Next, we are doing 30 divided by 5, which is 6. And next, 51 divided by 5 is 10.2. Next one, 36 divided by 5 is 7.2. And then the last one, 18 divided by 15 is 1.2. Okay, so now we need to try and think of a scale that's going to work nicely with those numbers. So the biggest number we need to get up to is 10.2. So I'm going to make every 5 little squares be one whole. So then every 1 little square is 0.2. Okay, so there's the scale ready to rock. Now it's time to draw the histogram. So again, the rectangles have a base of the interval width and height of the frequency density. So you should get this. Okay, so there is the histogram in all its glory. And then for part B, we are asked to work out an estimate for the fraction of students that have a height between 150 and 170 centimetres. So, on the histogram, we want everything from here up to here. So, most of it we can do from the table. The bit that we can't is this bit here. So the area of this is going to be, well, it's got a width of 5 and a frequency density of 1.2. So 5 times 1.2 is 6. So we're going to need this 6 add the 3 middle totals. So going back to the table, we want all of those 3. So 30 and 51 is 81. 81 add 36 is 117. So we're doing 117 add 6 is 123. So our fraction is 123 out of 150. Next up, here is some information about the members of a sports club. So, the histogram, it's about their ages. So along the bottom, we have age A years. Now we don't have our frequency density. Now we are told there are 30 members with age less than 20, 12 members with age between 65 and 80. No members with an age greater than or equal to 80. Part A wants us to complete the histogram. So what we need to do is find the frequency density and then draw the final bar. So to do that, we are going to start with the fact that there are 30 members with age less than 20. So that means in this bar, the frequency or the area is 30. Now the width is 20, so the frequency density must equal 30 divided by 20, which is 1.5. So we know then, up to here, our frequency density is 1.5, so that's 3 notches up. So every notch, or 5 little squares, is 0.5. Okay, so that is that axis complete. So now that we have the frequency density, we can now work out how to draw the final bar. So there are 12 members with age from 65 to 80. So we know we want to draw it up to 80. Now this time we know the frequency density times 15 is 12. So divide by 15 and we get the frequency density is 0.8. Okay then, so the final bar will look like that. So then there is our completed histogram. Good times. Okay then, bar B wants us to work out the total number of members in the club. Okay, so we know there are 30 in the first bar. We know there are 12 in the final bar. So at the moment, that's 42. Okay, now the second bar in has a width of 10 with a density of 4.5, so there are 45 people in this one. The next bar also has a width of 10 with a density of 3.6. So there are 36 people in this one. And then in this chubby fellow down here, we have a width of 25 and a density of 2. So in here there are 50 people. So we just need to add 45, 36 and 50 and then add that to 42. So 45 and 50 is 95, and 6 is 101, and 30 is 131. So 42 and 131 is going to give us 173. Final question for this set, quite a tricky one. So, the histogram shows information about the speed of cars as they pass a checkpoint. The scale on the frequency density axis is missing. We are told the histogram shows information about 480 cars, and we're asked how many cars does the first bar represent. Okay, so for that we're going to need to know the frequency density. The way that we're going to do this is we know the total area has to be 480. So, given that the bars don't just go up to nice whole 5 little squares, I'm going to set 1 little square is equal to x. So, 1 little square is equal to x. So, on the first bar, we're going to have 25x, and the width is 15. So in here, we have 15 times 25x. Now that is gonna be 375x. Okay, then in the next one, the interval is 5, and the density is 33x. So in here then, we have 5 times 33x. Which is 165x. And then in the final bar, the density is 4x. And the width is 15. So 15 times 4x is 60x. Okay, so the reason for doing that is that we now have, or we can work out, an expression for the total number of x. And we know that has to equal 480. So, if we do 375x add 165x add 60x, we are going to get 600. So we have 600x. Now that is an expression for the total area. We know the total area is 480. So 600x is equal to 480. So x is 480 over 600. Which is 0.8. So, what that tells us is every one little square represents 0.8. Now, we know the area of the first bar was 375x. So, as a number, that's 375 times 0.8. Which, quite nicely, is 300. Okay then, for the final part, cars with a speed greater than 40 miles per hour are over the speed limit. We want to calculate an estimate for the number of cars over the speed limit. So, find 40 miles per hour, it's here. So we want the area of this bit. Now we know one little square is 0.8. We have 4 little squares, so that's 3.2. And then our width is 10, so 10 times 3.2 is 32. Okay then guys, that's all the fun for this one. If you want more histogram questions, I do have them. Make sure you give this video some love. Give us a thumbs up, get subscribed. For now, take it easy, take care.